Welcome everyone. So on the looking at the picture on the screen, you all can observe that Earth is rotating or revolving around the sun, and the moon, which is a natural satellite of the Earth, is revolving around the Earth. So today's topic is something related to attraction, something related to motion and force. Okay, so let's see what is our today's topic. Alright, so our today's topic is gravitation, and this is a part 1 video of this lesson, and this lesson is of class 10th physics. Okay, so in this video we are going to study about gravitation, what is circular motion and what is centripetal force. So these all topic we have to cover, we shall study in the today's video. So let's start one by one. Alright, so can you recall, student, what are the effects of force acting on an object? So here answer is effects of force. A force acting on an object causes the object to change its shape or size, to start moving, to stop moving, to accelerate or to decelerate. That means if you are applying force on particular object, so what happen, either it will start accelerating, it will come in motion, or it will stop its motion, or it will increase its speed, or speed will increases or its speed will be decreases. So these are the effects of a force acting on an object. Alright, so again one question is there for us: what types of forces are you familiar with? So there are different types of forces we have familiar with till standard 9. Alright, so there is frictional force, gravitational force, magnetic force, contact forces like push and pull, electromagnetic force and resistance force. These are some forces. Okay, I have listed here some forces which we have studied till standard 9. Alright, so one more question is there for us, that is, what do you know about the gravitational force? So student, you all can observe an apple is falling from a tree and it is falling towards an earth. It is not going in upward direction, it is coming towards downward direction towards the earth. Okay, so this is a force of attraction that is called as a gravitational force. So let's see proper definition. So gravitational force is a force of attraction that attracts any two objects. Okay, any two objects with different masses in the universe. That means this is a universal force of attraction which attracts any two objects with different masses. That means different weight they have. So this is a gravitational force. So student, we have seen in the previous standard that the gravitational force is a universal force. Alright, this is a universal force and it acts not only between two objects on the earth but also between any two objects in the universe. That is why it is called as a universal force of attraction. And let us now learn how this force was discovered. So let's see. Okay, so gravitational force, let's see how it has been discovered. So as we have learned, the phenomena of gravitation was discovered by Sir Isaac Newton. Okay, and as the story goes, he discovered the force by seeing an apple fall from a tree on the ground, and he wondered why all apples fall vertically downward and not to an angle to the vertical. Why do they not fly off in a horizontal direction? That means when apple falling from a tree towards the earth, Newton start thinking that why this apple fall vertically downward direction, why this is not fly off in a horizontal, that is in horizontal direction, that is in upward direction. Okay, so after much thought, he came to the conclusion that the earth must be attracting the apple towards itself. That is, earth is attracting an apple towards itself, and this attractive force must be directed towards the center of the earth. And the direction from the apple on a tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downwards. It is not going horizontal direction. Okay, so this is how the gravitation has been discovered by Sir Isaac Newton. Alright, so here one picture is given to us, that is it shows an apple tree on the earth, and the force on an apple on the tree is towards the center of the earth, is toward the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. So here you can observe the moon is there, earth is there, and gravitational force is there between moon and earth, and it is also there between the apple and the earth. All right. So, and the figure also shows the gravitational force between the earth and moon, and the distance which we have in the figure are not according to the scale. These are the approximate distance. Okay. So Newton taught that if Alright, so Newton taught that if the force of gravitation acts on an apple on the tree at different heights from the surface of the earth, can it also act on the objects at even greater heights, much further away from the earth, like for example the moon, and can it act on the even farther objects like the other planets and the sun? So as we have seen in the previous slide, that is gravitational force is a universal force of attraction. That means it can attract any two objects in the universe. So force of attraction, gravitational force is there like in the moon and earth, sun and the earth, it is there. But as the distance increases, that you are understanding now, as the distance increases, that means moon to the earth and sun to the earth, we know the distance is very greater. So as the distance increases, gravitational forces decreases. It is there, but it is in weaker point. Okay, like in apple and earth it is greater. Why? Because the distance is less na. But if we compare the distance between the sun and earth and moon and earth, so it is distance, as the distance is higher, so gravitational force is there, but it is weaker. All right. Okay, now let's see what are the force and motion. So force, it is obviously it is a push and pull. A force is a push or pull that cause an object to move faster or slower and stop, change in direction. So this is a force. Next is the motion. So what is motion? Alright, so motion is a change in position of an object with respect to its surrounding in a given interval of time. So just we can say the displacement also. It is change in position of an object with respect to its surrounding environment in a given interval of time. That means in particular interval of time, how much the distance has been or the displacement has been taken. That is motion. Okay, so can you recall again what are the Newton's laws of motion? So in 9th standard we have seen what are the Newton's laws of motion. So here I am listing the 3 Newton's laws of motion, and for the complete explanation you can check out my 9th standard playlist so that you can get a proper explanation of this laws. Okay, so first law is Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. And the second law, Newton's second law of motion, is the rate of change of momentum is directly proportional to the applied force, and the change of momentum occurs in the direction of the force. And the third, Newton's third law of motion is every action force has an equal and opposite reaction force which acts simultaneously. So these are the 3 laws. For complete explanation, you please go and check out my 9th standard playlist. Alright, now let's see what is the circular motion. Alright, circular motion. This is so simple. So circular motion is a movement of an object along the circumference of a circle or rotating in a circular path. So we can you can observe in the picture that is one ball or one particular object is there which is rotating in a circumference of a circle. Okay, so you can observe here the earth is orbiting the sun, and moon, which is a natural satellite, is orbiting the earth. So this is a circular motion as they are moving in a circular path or circumference of a circle. Okay, now centripetal force. Let's see what it is. So here a stone tied to a string moving along a circular path, and its velocity tangential diagram. So let's tangential direction. So let's understand this diagram. So student, here tie a stone to one end of the string and take the other end in your hand and rotate the string so that the stone moves along a circle as shown in the diagram. All right. So are you applying any force? Are you applying any force on this stone? Yes, obviously we will apply some force on a string. Okay. Now how, in which direction is this force acting? How will you stop this force from the acting, and what will be the effect on the stone? So student, we can observe here one stone is tying to the string, and if we will rotate the string, it will start moving in a circular path, or in a direction of the clockwise direction it will start rotating. Okay, and if we will stop applying the force, it will stop rotating. Okay, and stone will fall off. Okay, so as long as we are holding the string, as long if we are holding the string, we are pulling the stone towards us, that is towards the center of the circle, and are applying a force towards it. The force stops acting if we release the string, and in this case the stone will fly off along a straight line. You can observe here I have indicated this with a blue colored arrow. It will it will fall off along a straight line which is a tangent to the circle. Blue color arrow is indicating the stone is falling in a straight line, and this is a tangent to the circle. That's why it is called as the tangential direction. Okay. So tangent to the circle at the position of the stone when the string is released, because that is direction of its velocity at that instant of time. And you may recall that we have performed a similar activity. So this was all about a stone tied to a string moving along a circular path, and its velocity will be tangential direction. Okay, so student, this is the centripetal force. Now let's understand the proper definition of the centripetal force. Okay, so what is it? A force acts on an object moving along a circle, and it is directed towards the center of the circle, and this is called the centripetal force. And centripetal means center seeking force. Why? Because the object tries to go towards the center of the circle, and because of this force. So this is a center seeking force. Why? Because this is particular moving towards the center of the circle. All right, so here you can observe the centripetal force, which is attracting towards the center of the, that means objects is attracting towards the center of the circle, and it center of the circular path, and it will moving in a proper circular path. So this is all about the centripetal force. Okay, so you all know that the moon, which is a natural satellite of the earth, goes round it in a definite orbit, and the direction of the motion of the moon as well as its speed constantly changes during this rotation. That means when the moon will rotating around the earth, its direction will be same, but direction and speed constantly changes. We know now that this is moving towards one end till the another end, so its speed will continuously changes. And do you think some force is constantly acting on the moon? What must be the direction of this force, and how would its motion have been if no such force acted on it? Do the other planets in the solar system revolve around the sun in a similar fashion? Is similar force acting on them? What must be its direction? So student, in previous slide we have seen the stone is attracting towards the center of the circular path, and here also we are observing that moon is attracted towards the earth. That means here gravitation, the centripetal force is there, and gravitation is also there. That's why from this it is clear that for the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. And similarly, the sun must be attracting the planets, including the force towards it. So if gravitational force is not there, what happen? The moon will not revolving around the sun. Okay, but in a circular way, because moon rotate around the earth, gravitational force is there, and for the gravitational force, moon should be rotating in a circular path. So this was all about today's video, and next part of the video we can continue in our next session. Thank you all of you.